All right, let's jump right in. If you're getting ready for a Python technical interview, you know you've got to have those core concepts down cold. Well, you've come to the right place. We're going to walk through the absolute must-knows that pop up again and again. So, let's get into it.
Here's our game plan. First, we're going to explore what makes Python tick, its core identity. Then, we'll open up the essential toolkit of data structures you'll be using constantly. After that, we'll shift gears and talk about writing code the Pythonic way. And finally, we'll unlock some of those more advanced features that will really make you stand out from the crowd.
So let's start with the big one. Why Python? I mean, what's the secret sauce that's made it one of the most popular languages on the planet? It's not just for little scripts anymore. It's a powerhouse. So what's the deal?
To answer that, you really have to get into Python's DNA. This first part is all about understanding what makes Python, well, Python.
When you look at these features, you start to see a clear philosophy, right? It's all about making the developer's life easier. It's designed to be fast to write. You don't have to declare variable types. That's the dynamically typed part. And the fact that functions are first-class objects, whoa, that means you can treat a function like any other variable, which is just incredibly powerful. Now, the trade-off is that it can be slower to run, but don't worry, there are some brilliant workarounds for that.
Let's drill down on that first point. Being interpreted is an absolute game changer. It means you don't have this extra step of compiling your code before you can see if it works. You write a line, you run it, instantly. This is the magic that allows for the super fast development and testing that Python is famous for.
Okay, so we get the philosophy. Now let's talk about the actual tools you'll be using day in and day out. This next part covers your essential toolkit, the building blocks of data in Python that you absolutely positively have to know.
First up, the classic interview question. What is the difference between a list and a tuple? The magic word here is mutability. Lists are mutable. You can change them, add stuff, remove stuff, edit stuff. Tuples are immutable. Once you make one, it's locked in, set in stone. Now, why would you ever want that? Simple. That immutability makes tuples faster and, critically, safer for data that you never want to be changed by accident.
And here's another one that often trips people up: array versus list. They seem similar, but there's one huge difference. An array can only hold one type of data, all integers or all strings, for example. A list, on the other hand, doesn't care. It's a free-for-all. You can throw integers, strings, and even other lists all into the same collection.
And then you've got the dictionary. Honestly, this is Python's workhorse. It's all about creating these neat one-to-one relationships between a unique key and its value. So instead of an index number like 0, 1, 2, your key could be a word like user ID, and its value could be 1, 2, 3, 4, 5. It makes your code so much more readable and intuitive. It's fantastic.
You know, knowing the tools is one thing, but using them with skill, with elegance, that's a whole other level. This section is about moving from just writing code that works to practicing real Python craft.
And at the absolute heart of that craft is something called PEP 8. It's the official style guide for Python, and it all boils down to one simple, powerful idea: readability. The Python community believes that code is read way more often than it's written. So following PEP 8 just makes your code clean, predictable, and way easier for you and others to understand later.
And nothing, I mean nothing, shows Python's commitment to readability more than this. In so many other languages, indentation is just for style points. It just makes things look nice. Not in Python. Here, it's syntax. It's the law. That white space is how Python figures out what code goes inside a loop or a function. It literally forces you to write structured code, and if you mess it up, your program just won't run.
Now, when we start talking about object-oriented programming, we have to talk about underscore underscore, init. You can just think of this as the constructor or the setup method for a class. Every single time you create a new object, this underscore underscore init method is called automatically to get it ready, set up its initial state, and grab the memory it needs. It's basically the starting point for every object you'll ever make.
Python's OOT features are also incredibly flexible, especially with inheritance. You've got the simple stuff like single inheritance, where a class just inherits from one parent. But then you have really powerful stuff like multiple inheritance. This lets a class inherit from several different parents at once. Just imagine creating a flying car class that inherits all the features of a car class and a plane class at the same time. It's this ability to mix and match that makes it so powerful.
All right, you've got the fundamentals. Let's step it up a notch. We're heading into the final section to unlock some of Python's more advanced concepts, the kind of stuff that shows you're really proficient.
You ever stop and wonder how Python deals with memory? It's like having your own personal valet. See, all your objects are stored in this private area called a heap, which you can't touch directly. Python's own memory manager takes care of putting things there for you. And then this built-in garbage collector comes along and cleans up any memory that's not being used anymore. What's the point? It lets you focus on the fun stuff, your logic, not on the tedious work of managing memory.
So you're writing all this brilliant code. How do you keep it from turning into one giant tangled mess? Modules. That's the answer. A module is really just a Python file where you can organize your functions and classes. This lets you import that code into other projects, share it, and reuse it, which is how you build any kind of serious application. Plus, Python gives you a massive head start with a huge library of built-in modules for pretty much anything you can think of.
And now, let's tackle something that trips up so many people when they're learning. You've probably seen these weird-looking things in a function definition, args and quargs, and you've probably wondered, what on earth are those?
When you get down to it, they're actually just magic grab bags for creating super flexible functions. The one with a single star, args, lets you pass in any number of arguments and it bundles them all up for you into a tuple. The one with 2 stars, quargs, does the same thing but for keyword arguments and it bundles them up into a dictionary. It allows you to design functions that can handle all sorts of different inputs without breaking a sweat. It's incredibly useful.
And there we have it. That was our journey through 4 key stages. We started with Python's core identity, how it's all about readability. Then we looked at its essential toolkit, lists, tuples, dictionaries. From there, we talked about the craft of writing Pythonic code. And finally, we unlocked some powerful advanced features. Mastering these 4 areas will really set you up for success.
So we've cracked the code. We've seen the building blocks, we've seen the tools, and we've gotten a feel for the philosophy behind this amazing language. Now, the only real question left is, how are you going to use all this power and flexibility? What are you going to build? Thanks for joining me on this explainer.